Now, last week, of course, you became familiar with the unit step. And you know, it has the value of 1 for t greater than 0. And 0 elsewhere. So this is the unit step. But assume you have a t0, which is a positive number, like 2. And now I want to plot u of t minus t0. So if I consider t0 is here, and it's equals to 2, just as an example, it can have any positive value, then your unit step function would be the pink one, which has the value of 1 for t greater than 0 and 0 elsewhere here. So you can see now I have unit step with t0 shifting to the right. If you do the plot with the maple, it would be this. But now assume I want to plot u of t minus u of t minus t0. Maybe I should use another color. Have a different picture. So now I want to do u of t minus u of t minus t0. In this special case, t0 is 2. The first region I will consider is when t is smaller than 0, if t is between 0 and t0, and if t is greater than t0. If t is smaller than 0, it means that I'm in this region. Then the white color minus the pink color, which is 0 minus 0, so it will become 0. Am I right? So again, if I want to do it, the orange will come at the top of this one. Now let's look at this range. The white color is 1 minus 0. So 1 minus 0, which would be 1. So if I want to do the plot, I have the orange here. Make it smaller. So I just put it at the top of white, but it should. So this is the one. Maybe I'll do this as well. Okay. And if t is greater than t0, the white was here. So 1 minus 1, which is 0. So now the orange will be here. So now you can see I have only this area between 0 and t0. And if I want to do the plot in maple, the plot would be something like this. Of course, I use some t0 as a tool here. Now assume I want to make this a much more general, and now I have two number as t1 and t2. So now different color again. So I have t1, which is greater than 0, and t2, which is greater than t1 as well. So if I want to do the sketch here again, this is t. I have t1 here, and t2 maybe here. And now I want to obtain or do the plot of u of t minus t1 minus u of t minus t2. I think I need to go to another. Please take a picture of board number 1 because I need it. There's no space here. If you want, please take a picture.
Can you put the boards so it's possible to see all 4 boards?
Yes. Is it good?
Yes.
plot u of t minus t1 minus u of t minus t2. And maybe it's better to have the plot beside it, so when you want to take a picture, you don't need to take or move from two different boards. So I do the plot down here. T1 and T2. Okay. First, I do the plot for a u of t minus t1 with a green color. So if I want to do, we should have the unit step with t1 unit shifting to the right. So if 1 is here, it will become this one. So this is u of t minus t1. For the other one, I use the purple color. And again, I have the unit step with t2 unit shifting to the right. So it will become this purple one here. So the purple one is u of t minus t2. And 0 here. Okay. Now, I want to do the plot of the subtraction of these from each other. I will consider again different region. When t is smaller than t1, if t is between t1 and t2, and if t is greater than t2. If t is smaller than t1, we are in this region. And the green minus purple is 0. Yeah, I use the blue because I want to do the blue. Here. If we are in between, the green minus purple is 1 minus 0, which is 1. So we are here. And for another one is 1 minus 1, which is 0. So we are here. So you can see in a general case, again we have this box, but instead of being connected or attached to the origin, it is shifted. And it is in a range of T1 and T2. This purple one, not purple, sorry, blue one, which you see here, and also this orange one, which you see here, it's a good example of the piecewise function, or I think in Danish they call it stykkevis. I have it here. So these are a very good example of this type of function. And here, what you see in a slide is what I have here, and this is the plot corresponding to that. So please take a picture, and then you can copy and paste it on the next slide, so you have a plot there as well. And why I showed you this to you, because we need them for the next rule, which I will, on the LaPlace, which I will introduce to you maybe in 1 minute. And then after the break, we will use it for an example, which for sure you will have such an example in exam. And if you learn it, you can get around 15 to 20% of your final exam grade. So usually, I always give such a problem to students. So you can also find it in a previous exam sets, which is in Learn, that always the students had one type of this example. But for now, let me introduce the new rule or theorem on a LaPlace, which in English we call it the second shift theorem, and here is the name in Danish. What does this rule says? It says that function, then the shape or the structure would be only for the positive range of t, because it's the multiplication with u of t. Then the Laplace of it would be capital F of s. This is how the definition of Laplace is. Small f will become capital F, and of course in a frequency. Then the second shift theorem says that if you shift your signal, assume this first one is your function f of t times u of t. Now if you shift the signal both in a f and u term, the same amount, so t0 shifting to the right, then based on this rule, the Laplace of the shifting function would be always and always e to the power of minus t0s, and t0 comes from the amount of shifting you have, multiplied by f of s, which is the Laplace of the function without shifting. And of course you can rewrite this in this way as well. So both, this third line is the same as the combination of these two. So if you have a signal and then you shift it t0, then the Laplace of it would be this formula. I think you can also find this rule in a table 7.3, and we will use this after the break. Now let's have 15 minutes break. We will back to the room at 9.